Hello everyone, welcome to MindMatrix. So in this video, we will be solving questions of digital logic subject from GATE previous year 2023. So let's start the video. So before starting, let me introduce myself. My name is Anshul Sharma. I'm upcoming software engineer too at Juniper Networks. Currently, I'm pursuing M.Tech in computer science from IIT Kanpur. And I have more than 2 years of teaching experience, mentored more than 1,000 students as of now. And I have the expertise in computer science and data science subjects. Also, I have secured All India Rank 294 in GATE Computer Science, cleared ISRO NIC NELET exam. Also got selected as Administrative Officer at IISc. So that was my introduction, and here you can join our doubt discussion Telegram group. So you can scan this QR code, and here we have this MindMatrix official Telegram doubt discussion group. You can join and you will be able to ask your doubts there. Plus, we will be posting the PDFs of all the lectures that we are conducting on our MindMatrix YouTube channel. So before starting, I would request you to like this session, share with your friends, those who are preparing for GATE 2024-2025. Okay, and also subscribe to MindMatrix. So this is the first question that we have on our screen, and that was asked in GATE 2023 from Digital Logic. So let's read the question first. The output of a two-input multiplexer is connected back to one of its inputs as shown in the figure. So as you can see, we have a multiplexer here, which is a 2x1 multiplexer. So you can see the output of this multiplexer, we are giving it as one of the input to the multiplexer. Now we have to match the functional equivalence of the circuit to one of the following options. So here it is saying functional equivalence. That means it is performing the same task. Okay, so this multiplexer is given to us. We have to figure out whatever task it is performing, is it similar to D flip-flop or D latch or half adder or demultiplexer? That we need to find out. Few of the options you can directly eliminate here. As you can see here, it is a multiplexer, and in case of demultiplexer, it is reverse of multiplexer. Basically, if we have a multiplexer of 2 raised to the power n by 1, where n is the number of select lines, so demultiplexer is going to be the reverse of that. Basically, demultiplexer will have this form, so which is not there as we can see in the figure. So definitely demultiplexer is not the correct answer here. Okay, what about half adder? As you can see, that in case of half adder, we don't have anything like the output is giving the output is given as the input to the multiplexer here. So half adder is also we can clearly eliminate. Also we can substitute the values and we can find it out. Now we have two options left, that is D flip-flop and D latch. So let's try to write the characteristic equation for this given multiplexer, and let's try to find out whether it is equivalent to D flip-flop or D latch. Okay, now let's see here. We have, let's say this is your I0 input and this is your I1 input. Okay, so S is our select line here and Q is our output. Now if I want to write the characteristic equation, let's say it is the output is Y, so I can write Y is nothing but, if S complement, then I'm going to select the I0 input. I'm going to write like this, plus if S value is 1, that means not a complement, then in that case I will be selecting I1. In this way we write the characteristic equation. Hope you are aware of the concept of multiplexer. So we can write the characteristic equation here in this form. Now we need to find out here, as we know, in case of let's say a D latch, we have the enable inputs, right? We have the enable input, and when we talk about flip-flop, we have what? Clocks. Now here also, if you see the figure, there is no concept of clock involved here, so we can also eliminate D flip-flop. But let's find out why it is, why it can be D latch here. So enable input, in case of enable input, in case of D latch, when enable value is 0, then there will be no change in the output. Okay, then that means we can say the next state Qn plus 1 will be same as the previous state when enable is equal to 0 in case of latch, D latch. When enable is equal to 1, in that case whatever is your input, that is going to be the output. This is how the D latch behaves, right? Now, carefully see here. Let's say if I make it, let's say if I substitute S is equal to 0, in that case, Y will be nothing but I0. When S is 0, Y will be nothing but I0. Because S is 0, this term will become 0, S complement will become 1, and Y will be equal to I0. So as we can say, when S is 0, Y is equal to I0, that means the output is nothing but the previous state, because I0 is what? I0 is nothing but the previous output, right? We are giving the previous output, the output of this multiplexer, we are giving it to the input of I0. So in case of S0, Y is nothing but I0. So we can clearly say that this S can behave here like enable. So when enable is equal to 0, the current output will be same as the previous output. Okay. Now when S is equal to 1, in that case, Y will be equal to I1. That means whatever input you are giving, that is going to be your output. Whatever input you are giving, that is going to be your output. As we have in the case of enable, when E is equal to 1, whatever input we give, we get that as the output. In case of D latch, so we can clearly say that this is nothing but a D latch. This given multiplexer is having the functional equivalence as the D latch. So option B is the correct answer for this question. Very simple question. Few options you can directly eliminate also, right? And few options you can find it out by writing the characteristic equation of the multiplexer. In this way you can solve this question. So that was quite easy question. Let's proceed to the next question, that is from number system. So question number 2, it says a particular number is written as 132 or 132 in radix 4 representation. The same number we need to find out its radix 5 representation. What do you mean by radix? That is nothing but base. Okay, that is nothing but base. That is base of that given number. Okay, like binary we have, so number will be either 0, 1 in 0 ones, right? So similarly in decimal we have from 0 to 9. So here it is radix 4. So we can say that 132, it is given in the base, in base 4, right? It is given to us in base 4. And we need to find its equivalent representation in base 5. That we need to find out here. Very simple question. Whenever we have these type of questions, when there is a base, a number given in different base, and we need to convert into some other base, so it is better to convert that first in your decimal number system. Okay, it is better to convert that in the decimal number system. So here 132, there are two ways to do that. First, in order to convert into decimal number, what we can do, 1 into 4 plus 3, that will give you what? 1 into 4 plus 3, that will give you what? 7. And then 7 into 4, then what is remaining? 2. So that will give you 30. This is one way of converting into decimal. Basically what we are doing is, we are doing this thing, that 1, we can write from here, let's say 2, this is 2. So 2 into 4 raised to the power 0 plus 3 into 4 raised to the power 1 plus 1 into 4 raised to the power 2. The same thing we are doing in this way. So 1 into 4 plus 3, that gives you 7. Then 7 into 4 plus 2, that gives you 30. And this also is going to give you 30. So this is 16, and this is 12, and this is 4 raised to the power 0, 1, that is 2. So this will give you 30. So its equivalent is 30, right? Its decimal equivalent is nothing but 30. And now we need to convert this into base 5. So what you can do is, we have 30. we know, like, if you follow this pattern, we know, like, if I want to convert into, a base 5, so it should start like this: 5 raised to the power 0, then multiply by something, plus 5 raised to the power 1, then multiply by something, right? Then 5 raised to the power 2, then multiply something, and so on, right? So if you write this again, so 5 raised to the power 0 is nothing but 1, right? Plus this is 5, plus this is 25. This is 25, right? Now if you add all these up, you will be getting what? 31. But we want 30, right? So what we can do is we can substitute 0 here, we can substitute 1 here, we can substitute 1 here. So this will become 0, and this will give you what? This will give you 30. So the representation would be 1 1 0. This is one way of doing it. Like you can say basically a shortcut, right? Or if you are not comfortable in this way, so what you can do is, let me show you the other way also. So what you can do here is, you want to convert that 30 in base 5, so let's do it here. So if you divide it, so what do you get? If you divide it, what do you get here? That is quite simple. So it is going to be 5 6 is 30, because it is in base 10. So the remainder will be 0, and here it is 5 1s are 5, so remainder will be 1, and this is the representation, that is 1 1 0. So I hope it is clear. Both ways you can do, either you can follow this one or you can follow this one. Both will give you the same answer. So here the correct answer is 1 1 0. So 1 1 0 in base 5 is equivalent to 132 in base 4. Okay, so let's proceed to the next question now. So here we have the third question, that is from sequential circuits. Consider a sequential digital circuit consisting of T flip-flops and D flip-flops as shown in the figure. Now clock in or CLK in is the clock input to the circuit. As we can see, we are giving the clock to the circuit, to every flip-flop, right? That is the input clock. Now at the beginning, that means at the initial stage, Q1, Q2 and Q3 have values 0, 1 and 1 respectively. That means initially, if you talk about Q1, Q2 and Q3, the initial values are 0, 1 and 1. Clear? Which one of the given values of Q1, Q2, Q3 can never be obtained with this digital circuit? Can never be obtained with this digital circuit, that we need to find out. So out of these options, there is one value which cannot be obtained by this circuit, and that we need to find out. So let's solve this question first. So let me write here just the initial state given to us is 0, 1, 1, right? Now before solving this question, this is very important to understand how a T flip-flop and D flip-flop behaves. So I hope you are aware of the concept, but still let me tell you this. When the value of T flip-flop is 0, so there are two possible values, right? Either the value of T is 0 or the value of T is 1. Now if the value of T is 0, it is nothing but it is going to retain the same state, retain the previous state. But in case if T is equal to 1, in that case it is a case of toggle. So whatever is your previous state, it is going to toggle it. Whatever is your previous value, it is going to toggle it. So this is how a T flip-flop behaves. What about D flip-flop? So in case of D flip-flop, whatever is your input, if your input is 0, the output is going to be the same. We can say it is going to behave as the same. That means whatever is your input, it is going to give that as the output. Similarly, if D is 1, it is going to give that as the output. That's how D flip-flop behaves. Whatever is your input, that is going to be your output. Clear? Now, in order to solve this question, you need to first write the equations. So we need to find the next state, right? So I can write here we have Q1, we have Q2, we have Q3, and here we have Q1n, we have Q2n, and we have Q3n. So Q1n, Q2n, and Q3n represents the next state. Okay. Now carefully see here, initial state that is given in the question, that is 0, 1, 1. So we can say initial state is, we can write here, initial state is 0, 1, 1. Okay, initial state is 0, 1, 1. Now in order to solve this, we need to first write the equations. So carefully understand, when we can write for Q1n, we need to write for Q2n, and we need to write for Q3n. In case of Q2n, as it is a D flip-flop, so we can say Q2n is going to take the value of D, and D is what? D is taking the value of Q1. So basically we can say Q2n is nothing but Q1. As I explained you, whatever is the input, in case of D flip-flop, whatever is the input, that is going to give you that output. So here Q2n is taking the input as D, and D is what? Q1. As you can see, Q1, the Q1 value we are giving to D, and D is going to whatever is your input, you will be getting that as the output in Q2. Clear? So this is the equation for Q2n. Now we have to write the equation for Q1n and Q3n also. So let's denote this, as this is a first flip-flop. Let's write T1 here. This is a second flip-flop, so let's write a D2 here. Just a minute, let me just erase this thing. Okay, now so let's write D2 here, and let's say this is T3, just to know, like if there are, as there are two T flip-flops, so just to differentiate between them. Okay, so that we don't commit any mistake, and you also need to do that in that way. Right, now carefully see this. In case of T flip-flop, as I told you, when T is equal to 0, it retains the previous state. If T is equal to 1, it is going to toggle it. Now Q1n, the next state, Q1n will depend on the value of T1. Q1n will depend on the value of T1. And what is T1 actually? T1 is taking the input from the Q3 complement as Q3 complement. So we can write here T1 is equal to Q3 complement. So now your Q3 complement will decide the value of T1, and your T1 will decide eventually the value of Q1n. It is very simple. Don't worry, you will be getting the entire concept clearly. But we need to do it in a proper way. Now, so T1 value is equal to Q3 complement. Simple. Yes. Now what about Q3n? Q3n also depends on the value of T3. And what is T3 actually? T3 is equal to Q2. So T3 is equal to Q2. That means whatever is the value of Q2, that will decide the value of T3, whether it is 0 or 1, and that will eventually decide the value of Q3n. So I hope how to write the equations, I hope that is clear to you. Now let's start solving this question. So initially your state is 0, 1, 1. Now let's say I give the first clock. So when we give the first clock, what is going to happen? Q2n will take the value of Q1. So whatever is Q1, that is 0, we are going to write here as 0. Clear? Now, now what about Q1n? Now carefully see, Q1n will depend on the value of Q3 complement. So Q3 complement, here it is 1. Q3 complement means 0. So T1 value will become 0. That means if T value is 0, it is going to retain the previous state. That means whatever was Q1, that is going to be same as Q1n. Okay. So we can write whatever is the value of Q1, that is going to be the value of Q1n. It is going to retain the same state. Why? Because T1 value is equal to 0. Clear? I hope it is clear now. Now, what about Q3n? Q3n is taking, so T3 is taking the value of Q2. For Q3n, T3 is taking the value of Q2. Q2 value is 1. That means T3 value is 1. T value is 1. It is going to toggle. So in case of toggle, Q3n will be Q3 complement. So in the previous value of Q3 is 1. So it is going to become 0. Clear? Let me write it more clearly for all of you here. So let me write in this way. If T3 value is 0, there are two possibilities. T3 value is 0 or 1. If it is 0, in that case Q3n will be equal to Q3, and in case of T3 value is 1, Q3n will be equal to Q3 complement. I hope now it is clear, right? Similarly here also we can write if T1 value is 0, just a minute. Yeah, if T1 value is 0, in that case it is going to be Q1, because it is going to retain the same state. So Q1 will become Q1, Q1n will become Q1 only, right? It is going to retain the same state. If it is 1, in that case it is going to become Q1 complement. So this is how we write the equations completely. I was doing directly, but now I hope it is clear if you are lacking in the concept. Okay. Now, so after giving the first clock, we are getting 000. Now this 000 will be our previous state, because now if I'm going to give the second clock, so this 000 will become the previous state. Now we need to find the next state again. Q2n is equal to Q1, Q2n is equal to Q1, Q1 value is 0, so it is going to be 0 here. What about Q1n? Q1n, as it depends on the value of Q3, so Q3 complement, here it is 0, Q3 complement means 1, so T1 will become 1. In case of 1, it is Q1 complement. In case of 1, it is Q1 complement. Q1 complement is 1 here. Clear? Similarly, Q3n. So Q3n depends on the value of basically Q2 indirectly. Q2 is a 0, so T3 will become 0. Retain the previous state, Q3n is equal to Q3 only, so here it is going to be 0. Now again, if I'm giving the third clock, so this 100 will become my previous state, and I'm going to get the next state. Q2n is equal to Q1, so Q2n is equal to Q1. Here it is 1. Fine, we can write clearly. Q1n will depend on the value of Q3. Q3 complement, here it is 0. Make it so Q3 complement is 1. So T1 is 1. So it is going to be Q1 complement. Q1 complement, here it is 1. Here it becomes 0. Clear? What about Q3n? Q2 value is 0. To T3 is 0. Retain the same state. So Q3n will take the same value as Q3. That means 0, 1, 0. Again, if I give the next clock, so it is 0, 1, 0 will become my previous state. I'm going to get the next state. Q2n is equal to Q1. So here it is 0, here it is 0. Q1n will depend on the Q3 value, complement basically, Q3 complement. So 0 complement is 1. So T1 is 1. If T1 is 1, I will be getting Q1 complement. So here it is 0. So I will be getting 1 here. Similarly, Q2 value. So Q2 is a 0 here. So T3 is 0. Retain the same state. Here it is 0. Here it is 0. So I will be getting 1. Sorry, Q2 value is 1 here, right? Q2 value is 1 here. Just a minute. Carefully see here. Q2 value is 1 here. So T3 will become 1. So Q3 complement. So here it is 0. Here it is 1. Yeah, now it is correct. 1, 0, 1. Again, if I give the next clock, Q2n is equal to Q1. Q1 is 1. So I can write 1 here. Right. Now what about Q1n? Q1n, Q3 complement. So 0. T1 will become 0. So it is going to give Q1 as, or basically we can say retain the same state, Q1. So 1 here. So 1 here. Q3 and Q2 value, Q2 is a 0 here, right? So T3 is 0, retain the same value, 1 here, Q3, 1 here. So we are getting 111. Now if I give the next clock pulse, so 111 will become the previous state. I'm going to get the next state after giving the clock pulse. Q2n is equal to Q1, Q2n is equal to Q1, so 1 as it is. And here Q3 complement in case of Q1n. So that becomes 0, Q3 complement. T1 will become 0, retain the same state. Here it is 1, here it is 1. Here it is Q2, Q2 is 1. So T3 will become 1, T3 1, that means toggle complement, right? So it is Q3 is 1 here, it is going to become 0 here, 1, 1, 0. Again, if I give the next clock pulse 1, 1, 0, so what do I get? Q2n is equal to Q1, Q2n is equal to Q1, 1 here, so I will be getting 1 here as it is. What about Q1n, Q3 complement? That means 1, T1 will become 1, toggle Q1 complement. Q1 is 1 here, you will be getting 0 here. Q3, yeah, Q3n, right? So here Q2 is 1, toggle, Q2 is 1, toggle, T3 is 1, Q3 complement. Here it is 0, here it is 1. Now if you see here, we are again getting the initial state. We are back to the initial state. That means these are the states possible that, these are the possible states that can be generated by this given circuit. And we need to find which state we are never going to get from this circuit. So here, can we get 0, 0, 1? Let's see. Do we have 0, 0, 1 here? No. So 0, 0, 1 is not possible. So option A is the correct answer. What about 1, 0, 0? So if you see here, yes, 1, 0, 0 is there. So that can be generated. What about 1, 0, 1? 1, 0, 1 is also there. What about 1, 1, 1? So 1, 1, 1 is also there. Right, so that means option A is the correct answer for this question, and this is the state, or these are the given values that can never be obtained with this circuit. I hope it is clear. I have explained you in lot of detail, and you can try to solve this question again by yourself just to practice again. Okay, let's proceed to our last question of today's video. So that was also asked in GATE CS 2023. From digital logic. So a Boolean digital circuit is composed using 4 input multiplexers M1 and M2. So we have one M1 multiplexer, M2 multiplexer, and it is 4 input multiplexer. So basically it is 4 by 1. Here this is also 4 by 1 multiplexer. Okay. Now, and one 2 input multiplexer M3. So we have M3, that is 2 into 1 multiplexer. Okay. Now X0 to X7 are the inputs of the multiplexers M1 and M2. So as you can see, X0, X1, X2, X3, X4, X5, X6, S7. These are the inputs to these two multiplexers and could be connected to either 0 or 1. That means it can have the value either 0 or 1. The select lines of the multiplexers are connected to the Boolean variables A, B, and C. So we have the select lines here, AC, AC, and B. Basically, we have 3 select lines. AC we are giving to M1, again AC we are giving to M2 also, and B as a select line we are giving to M3 multiplexer. Clear? Now we need to find out which one of the following set of values of X0 to X7 will realize this given Boolean function. That we need to find out. So what can be the possible values so that we can get this final Boolean function here? Okay, that we need to find out. So let me write, so here we have this function. So let me write here again, it is A complement plus A complement C complement plus A B complement C. Now one way of doing it is, so here what you can do is you can try to write this, or you can try to simplify first, and then you can try to write this Boolean function in terms of A, B, C, right? So let's try to do that. So here if you see A complement is common, so I can take A complement common, and it is going to become 1 plus C complement plus A, B complement C. Here 1 plus anything, or 1 or anything, basically if I'm saying plus, that means or operation. 1 or anything is going to become 1 only, so I will be getting A complement. This is going to become 1, so A complement or A B complement C. This is what we are getting. Now what we can do is we can try to write this equation or this function in the complete canonical SOP form. So so what we can do is I can write here like this. Let's say here I can write it is going to B plus B or B complement, C or C complement, right? Because here B and C is missing, right? B and C is missing, as I have, let's say, A complement. Here B and C is missing, so that means it is nothing but 1, and 1 I can write as B or B complement. Similarly, this I can write as C or C complement, right? And here it is A B complement C. So what do I get? I will be getting A complement B or A complement B complement, and here it is C or C complement. Further we can expand it. So I will be getting A complement B C or A complement B C complement, right? And here I will be getting A complement B complement C or A complement B complement C complement, and here it is A B complement C. This is what we are getting. Now if you see in this question, for the last multiplexer we have B as the select line. That means if I want to write the equation, characteristic equation for this last multiplexer, I will be writing something like this. If it is B complement, then I will be selecting this I0, and if it is B, then I will be selecting this I1, right? So that means we need to find out I0 and I1 here, and in terms of this we can write B complement and B. In terms of this we can write, so if I see B complement term, we have B complement here, here and here. So can I write B complement? If I take common B complement, I can write A complement C, or from this one I can write A complement C complement, or from this one I can write AC. And what about B term? So from these two I can take B common. So I will be getting A complement C or A complement C complement. This is what we are getting. Now what we need to do? So we have found out this I0 and I1, the possible value of I0 and I1. Now we need to find, based on these two, we need to find what can be the possible values of x0, x1, x2, x3, and from x4 to x7, what can be the possible values, because these two multiplexers are having the select lines as AC. So let's consider only M1. Let's consider only M1. So if I consider M1 multiplexer, its characteristic equation will look something like this: A complement C complement x0, A complement C x1, A C complement x2, AC x3. It will look something like this. Similarly for M2 also, just you can replace with x4, x5, x6, x7, and it is going to look like this only. Now if you see here, if we are talking about here from M1 multiplexer, this is representing M1 output and this is representing M2 output, right? So here if you write this function in this form, so what do you get? A complement C complement term is present here, so definitely x0 value will be 1. A complement C term is present here, so definitely x1 value will be 1. AC complement term is missing here, so x2 value will be 0. AC is there, so x3 value is 1. So can I say x0 is equal to 1, x1 is equal to 1, x2 is equal to 0, and x3 is equal to 1. Now similarly, if I talk about M2 output, so here A complement C complement is present here, so can I say x4 for M2? Can I say x4 is 1? A complement C term is also present here, so can I say x5 is going to be 1? And other two terms are missing, so can I say x6 is equal to 0 and x7 is also equal to 0? So the possible values we can have, now if I write all the values again, so what can be the possible answers here? Only one possible answer is here, but if you try to write it from x0 to x7, the sequence you are going to get is 1 1 0 1 1 1 0 0. This is what you are getting: 1 1 0 1 1 1 0 0. So these are the possible, these are the set of values that is possible for x0 to x7. So if you match with the options 110 111 0, no, this is not correct. 110, this is also not correct. 110 111 yes, option C is correct. Option D is also incorrect. So option C is the correct answer for this question. So that's it from this one. So I hope you enjoyed this session. You learned a lot from this one, as I explained all the questions, previous year questions, as I solved all the previous year questions in a lot of detail, and I also explain you the concept behind each and every question. Okay, so you can join our doubt discussion Telegram group and WhatsApp channel. The links are given in the description, and also on our MindMatrix YouTube channel. So there you can join these two, this channel and this group, And don't forget to like, share, and subscribe to MindMatrix, because as we are providing the best quality content to all of you. So, and we will keep on providing that to you. So keep preparing and share with your friends. You can join doubt discussion telegram group by scanning this QR code as well, where you can ask your doubts, and you will be also getting the PDFs of all our sessions that we are taking on YouTube. So we'll see you in the next video. Till then, take care and bye bye. Thank you.